Alrighty, so thank you, Chris, for the intro. We'll just get started on the questions. So again, if you guys have any questions, just feel free to ask them in the Q&A. Chris has left my room, so I'm going to take off my mask. Okay, so I'm going to jump straight into it. And basically, we're just going to go through each question and kind of go through the approach you guys should think about when you see these kinds of questions. So I'm actually going to put my iPad down so I can kind of notate on the iPad as well, so you guys can see where I'm reading through. So question 1, recently in parts of the Northwest, many farm animals have been found killed in fields owned by local farmers. Analysis of these animals found that flesh had been bitten and torn away from the carcasses. The bite mark left behind also matched the typical patterns of bite marks seen in most big cat species. Wildlife experts note that the only big cat species endemic to this area was the native cougar. Which of the following best expresses the main conclusion of the argument above? Okay, so for this type of question, it's looking for the main conclusion. This essentially means that you synthesize the information in the stem, in this paragraph that they give you, and figure out what was the main purpose. Why did the author write this? Okay. So, obviously we can tell that this is written in an informative style. It's simply telling us facts, and it's piecing together certain pieces of evidence, right? It's telling us about these farm animals that have been found, and then the results of analysis and how this analysis correlates to pieces of information, right? Analysis of the bite marks, which correlates to certain big cat species, and how big cat species only have the native cougar endemic in their area. And so based on this information, we can figure out that the answer here would be A, right? The recent attacks on the farm animals must have been by big cats such as the cougar. And again, from this particular stem, you piece this together just by looking at how each piece of information goes on to the next. Why are they trying to talk about, these recent farm animals that have been killed? And what line of reasoning has resulted in them now wanting to point out the analysis and the results that came from this analysis? And then what kind of bite marks this might correlate to. Okay, so briefly going through the other questions, big cats are very detrimental to farms around the world. So this is a little bit irrelevant. It talks about, a broader scope than what the actual stem is talking about. We don't have any context about farms around the world, just in the Northwest. The recent deaths of many farm animals are unlikely to have been caused by other local townsmen. Again, the text doesn't really make any reference to other local townsmen. So this is, again, using irrelevant information. And D, there must be a large population of big cats in the Northwest. So they do say that the only big cat species in the area was a native cougar, but there's nothing about this text that talks about whether or not that's a large population or not. So A here would be the best answer. Okay. So someone's asked endemic. What does the word endemic mean? The word endemic essentially means that this particular species is common in the area, right? Particularly when we're talking about animals, it essentially means that this animal typically exists in a certain population in this area. Almost like it's part of the local wildlife. Okay, going on to question 2. The stacked bar chart shows retailers' annual book sales in 4 categories. Children's, symbolized by CH, adult nonfiction, symbolized by AN, adult special, symbolized by AS, and adult fiction, symbolized by AF. And now they've given us a table to demonstrate this. So again, we have a legend here, so showing that different patterns in these bars correlates to these 4 categories that we've been told about. And we've also been given a set of axes to help us figure out what this bar chart is telling us again. So as it goes up, it's tens of thousands of, and this symbol indicates pounds in terms of their sales. And then each category here is going to indicate the year. So the question here is asked, in which year did the smallest proportion of sales come from children's books? So they're looking for the smallest proportion. The smallest proportion indicates in which year was children's books, and again, keeping in mind the notation here, that's CH, which is these diagonal bars. In which year did these diagonal bars from the smallest proportion of the total sales that year, right? So essentially, this is, you're going to have to look at these bar charts and you're going to have to figure out, based on the total size of that bar, right, what is the rough proportion of this small bar in the middle, right? And you can do this by estimates of the numbers they correlate to, or you can just do this by the eye test, okay? So just by doing it by the eye test, you can see that 2006 clearly has the largest bar, and it also has the smallest amount, not just the proportion, but the smallest amount of that sold of children's books. And so as a result, you can clearly conclude that C, 2006 will be the answer, because it's the smallest amount of children's book in the year that saw the largest total amount in terms of dollar value. The alternative here would obviously be to make an estimate of the numbers of tens of thousands of children's books sold each year, and then make an estimate of total sales each year, and then find that as a proportion. Okay. So I'm going to move on. Question 3. A recent survey found a 40% decline in the number of people taking out new gym memberships over the year of 2021. This demonstrates that we as a nation are becoming less physically active and could face many negative health consequences as a result. To counteract this, more programs and incentives need to be put in place by the government to encourage the populace to engage in more regular exercise. Which of the following is an underlying assumption of the above argument? So this is an underlying assumption question. What that means is it's looking for a piece of information that is not stated in this stem, but must be true for this argument to still make sense, okay? So the best way to do this is to go through each option and then correlate that back to your understanding of the argument they're trying to make. So firstly, what is the argument they're trying to make? Well, they're saying that not a lot of people have taken out gym memberships this year, which means we're not very fit, which means we're not very healthy. So what this means is the government should put in place programs and incentives to then encourage us to exercise again, okay? So if we go through each option, A, rates of obesity have slowly increased over the last 2 decades. Well, there is no indication that this has assumed any sort of long-term trend in rates of obesity. There's no information, and none of the argument hinges on this kind of long-term trend. B, to date, the government has not engaged in any programs to promote the benefits of regular exercise. It is saying that we need to put in place more programs and incentives, but it doesn't say anything about what programs we already have. So we can't assume that we haven't engaged in any programs, right? We can't make that assumption because we don't know. They haven't told us this, and it's not important for this to be true for this argument to make sense, okay? C, gym memberships are the only way for the vast majority of people to engage in regular physical activity. So this is going to be a good assumption for us to pick. And the reason why is because, again, it is not stated in the text, but the text does say that they correlate the decline in people taking new gym memberships to the fact that we are not as healthy, right? And they've made this link between decreasing gym memberships and being not as healthy, right? And that link assumes that the best way for people to stay healthy, to do regular physical activity, is to have that gym membership, right? But obviously that's the assumption this paragraph has made, right? And there's a possibility that gym memberships might not be the best way, or might not be the most common way for people to engage in physical activity. So C would be the answer, because it is an assumption that is important for this argument to still make sense. D, gym memberships are the most effective way to maintain one's fitness. Again, you might assume this is true, but it's not an assumption in this argument, right? And this assumption is not something that this argument needs to be true, right? It's not about what's the most effective way. Different things can have different effectiveness, but they're looking at this decrease in people taking gym memberships as an indication that we're just becoming less fit. Okay, question 4. Jason enters a weightlifting competition. The competition is held over 3 rounds, where each contestant attempts and records the heaviest weight they can lift each round. Contestants will then receive prize money after each round, depending on how much weight they were able to lift according to the table as shown below. So here's the table. Over the course of the competition, the sum of the weights Jason lifted in each of the 3 rounds was found to be 359 kilos. What was the maximum amount of prize money Jason could have received in total over the course of this 3-round competition? Okay, so this question is essentially the type of question where they're going to give you a lot of information, but you don't need all of it. So when you go through this table, you don't need to read each row and correlate each set of weights to the dollar value. As long as you understand what the table is trying to say in general, you can then refer to it once you know what question they're actually going to ask you. Okay. So again, it's a 3-round competition, and you're essentially trying to, the way the game works is the heaviest weight you lift in each of your 3 rounds corresponds to how much prize money you're going to get for that round. And there are 3 rounds in total. So we do know that Jason lifted over the course of the 3 rounds, 359 kilograms in total, right? So if it's 359 kilograms in total, right? Ordinarily, this isn't enough information to figure out how much prize money he's going to win, right? But because 359 is so high, right? And we're trying to determine the maximum amount of prize money he could have earned, right? The best way to do this is to just assume that he wins he lifts 120 kilograms and earns $150. And that's so 121 kilograms and earns $150. And then in the second lift, he also earns 121 kilograms and earns $150. And in his third lift would be the remainder. Okay, so I'll write this out so it's a little bit more clear, right? Lift 121 kilograms. So the reason why I made the assumption that he lifted 121 kilograms is just because the question is asking for the maximum amount, right? So you're trying to figure out from this total weight, what was the maximum possible amount of money he could have won, right? And to do that, right, you want him to get that $150, right? But you want to try and assume that he lifted the least amount of weight possible to earn the maximum amount of money, right? Because that kind of number is going to be what results in the maximum amount of prize money overall, which is why I assumed 121, because I'm just nudging over that greater than 120 kilogram benchmark, right? So I'm going to do the same thing with lift 2, right? And we can see after lift 1 and lift 2, he's going to reach 242 kilograms out of his total 359 kilograms, right? So we can just minus this to figure out the weight of his third lift. And that's going to be 117 kilograms. So this is the way we try and figure out the maximum. And it's a bit of a logic puzzle, okay? And I will say that this is probably one of the harder questions in this test. So based on this, we figured out the weights, which will correspond to the maximum amount of prize money. And all you need to do is now just figure out the prize money, right? So 121 gives you $150. And then again, 150. And for the 117 kilos, that's going to give you $100. So you add those 3 together and you're going to get a total of 400. And as a result, that's going to give you the answer option B. Okay. Okay, so we have quite a few questions. I will double back and read some of these. For question 4, couldn't you just add 1, 2, 1, 3, 12, 13 times, and then the answer will be, okay. So the reason, so I think someone's asked, why can't you just, oh, okay. All right, I've just been notified by Kelvin that I'll go through all the questions at the end. So hold those questions tight and I'll circle back, but thanks for asking those and keep asking if you do have any, and Kelvin will get to them as he can. All right. I hope this made sense. I'm going to move on to question 5. So Sam competed in a 14-kilometer running race. The following statements were made. So with these kind of questions, right, they're going to give you a lot of statements, and then they'll often ask which statements with an S in brackets, so one or more statements above, prove that Sam completed the 14K marathon running race, right? And with these kind of logic puzzles, it's going to be a waste of time to read all 5 of them, right? What I suggest is actually to go through options A, B, C, and D, and just read the statements that they give you and see if those statements together help prove that Sam completed the 14-kilometer running race, okay? So I'm not going to read this. I'm just going to go straight for the options. A, statements 4 and 5. So what was statements 4 and 5? 4, Sam received a free bottle of energy drink. 5, Sam went to a party afterwards to celebrate his achievements. Do these two statements together prove that Sam completed the 14K running race? No, right? We just know that he received a drink and then he went to a party, right? We know he's celebrating his achievements, but it's not specific enough what achievements he made, right? He could have been, celebrating his achievement for finishing half of the race. We don't know, okay? Option B, statements 1 and 2. 1, free bottles of energy drinks were only offered to contestants once. 2, Sam drank a lot of water before the race and was feeling very confident. Okay, so this would be incorrect as well, just because we know that the statement 1 tells us that free bottles of energy drink were given, and then he drank a lot of water. They don't really link up to each other to prove anything, right? So there's no indication that he finished there. Go on to option C. 1, again, free bottles were given to contestants once, and statement 3 says free bottles of energy drinks were offered to all racers who were able to complete the race. And 4, Sam received a free bottle of energy drink. So this is actually going to prove that Sam finished the race. And this is because from statement 1, right, we know that the bottles of energy drinks were only offered once. From statement 3, we know that they were offered to all racers who could complete the race. And from statement 4, we know that Sam received one. If we know that they were already given one for everyone who ended the race, right, and Sam definitely received one, that proves that Sam definitely ended the race. He completed the 14-kilometer marathon, which indicates that C is the best answer, okay? Alrighty. Question 6. Overall, consumer surveys have found that healthier diets, low in calories and high in vitamins and minerals, have been shown to cost more on a weekly basis than foods with low nutritional value and high calorie counts. Okay. So student says, because the cost of healthy meals is higher on average, people from high income backgrounds will always be healthier than those from low income backgrounds, right? So the student's logic here, right, is because the statement said that healthier diets essentially cost more and less healthy diets, which have a lot of calories, will cost less than that, right? He's saying that, because of that information, people who earn a lot of money will be healthier because they can buy more healthy food, because the healthy food costs more, right? So if the passage is true, which of the following identifies a flaw in the student's argument? So we're looking to figure out why he went wrong, he or she. So A, individuals from low income backgrounds often have lower rates of obesity and heart disease than the average individual. So this doesn't necessarily indicate a flaw, right? Low income backgrounds having lower rates of obesity might suggest that, this entire logic is incorrect and low income backgrounds might be able to afford healthy food. But again, this is, a weakening argument, but it's not a flaw in his argument, right? Because a flaw in your argument has to be, something that you used as part of your argument that might not be correct, okay? B, individuals from low income backgrounds will typically be unable to afford more expensive, healthier food products. So this is essentially, restating the initial argument, right? So this isn't actually a flaw, right? This is actually part of the information that was given to us, okay? C, individuals from high income backgrounds are more likely to engage in other unhealthy behaviors such as smoking and alcohol intake. So again, the reason why this is not a great flaw to pick out is just because this isn't necessarily part of the information that was given, and it's external information to what the student's argument is. So what this actually is, it's a weakening argument, right? Because it's suggesting that the student is wrong when he's saying that high income backgrounds will always be healthier, because this argument is saying that high income backgrounds also engage in other unhealthy activities. But the problem is, this isn't a flaw in his argument, it's just a weakening argument, right? Because it's not an argument that the student used that's wrong, it's just an outside argument coming from another source, okay? D, individuals from high income backgrounds may not necessarily purchase more expensive, healthier food products, even if they are able to afford it. So this is a good weakening, this is a good flaw, right? Because it uses information that the student used. The student himself, him or herself, said that high income backgrounds will always be more healthier because of the cost of healthy meals being high, right? And option D is saying that, well, this isn't necessarily true. Just because they can afford it doesn't mean they're going to buy it, okay? So it's directly addressing something they said, and that's why D is the best answer here. Okay, going on to question 7. Sodium fluoride has typically been included in our tap water supplies as a cheap method of preventing dental cavities. However, society has gradually embraced better oral hygiene practices such as brushing teeth and flossing daily. This has improved the average level of dental hygiene in the country. Additionally, it has been found that sodium fluoride can be toxic, especially to children. As such, sodium fluoride should no longer be added to tap water supplies. Which one of the following, if true, would most weaken the above argument? So before we do this, let's summarize. What is this argument telling us? They're saying that sodium fluoride is included in our tap water, right? And its main property is to prevent dental cavities, but this is no longer as useful because we're so good at brushing our teeth and flossing. It's also mentioned that, sodium fluoride can also be toxic to kids. And the final conclusion that they've come to is sodium fluoride is not necessary in our tap water. So which of the following most weakens it? Let's look at A. There are very few reports where sodium fluoride in drinking water has been found to harm children. So this is a weakening argument, right? Because it's weakening the idea here that they've put out. Additionally, it has been found that sodium fluoride can be toxic, right? The thing is though, I know this isn't the answer because I have the answers, right? And I know that the reason why this isn't the answer is because there's another answer that more directly addresses a bigger part of their argument. So this is one of the harder questions where you have two answers that might be true, right? And this one could be true, right? But the problem is, once you go through the other options, you realize there's a stronger answer, okay? So going on to option B, which is the answer, oral hygiene practices like brushing teeth and flossing daily have not been shown to prevent dental cavities. So a core part of their argument is, because we brush teeth and floss really regularly, our dental hygiene is pretty good. So we don't need sodium fluoride anymore. But B is directly arguing against this and says that these practices don't actually prevent dental cavities, right? They might improve dental hygiene, but they might not actually prevent dental cavities, right? So this is directly arguing that sodium fluoride is still necessary, right? Because the need for it hasn't been proven to be unneeded. If option B is an argument to consider. C, sodium fluoride has not been shown to prevent the occurrence of dental cavities in children. So C is very similar to A. And I would say that C is wrong for the same reason as A. And D, communities in Sydney have recently protested the inclusion of sodium fluoride in their tap water supplies. D is kind of irrelevant, right? Just because a community has protested it, it doesn't necessarily mean anything towards the argument. Why did they protest it? Was there any merit to their protest? We don't know this, so D is irrelevant. Okay, on to question 8. Questions 8 and 9 refer to the following diagram. The stacked bar chart below shows the number of pupils or students with special education needs, SEN, and the number of pupils without SEN in 4 schools. So black is those with special education needs, and clear are those without special education needs. And they're labeled YXWV. So these are the schools, and these are just the number of pupils. So I just want to reinforce that reading these, it's really important to understand how to read these tables, right? You have, the scale and the axes to consider, as well as the legend that you have to look at. So question 8 says, Jefferson recently conducted a survey at his local primary school, Broadmeadows Public School, and found that 20% of the school's students were comprised of students with special education needs. Based on the stacked bar chart shown above, which of the 4 schools shown are likely to represent Broadmeadows Public School? So Jefferson's study said 20% of his school's students had special education needs, right? And now we're trying to figure out which of these 4 schools, right, correlates to the school that Jefferson goes to, right? And the only information we know is 20% of them have special education needs. Now, the only way to do this without just, doing a rough eye test is to actually look at the amount of special education needs students, and then look at the total amount of students in each school, and then find the proportion that those special education students make up, right? So that requires you to be able to read these tables, right? And so I know I skipped for one of the previous questions of similar working out to go by the eye test. I'll actually do the working out for this one to show you guys how you might want to approach it. So let's look at school Y. For school Y, right? Black is those students with special education needs, right? And if we look at the table, we can correlate that to around 50, right? Now, obviously, these are definitely going to be estimates, but they're going to be, quite accurate guesses, right? Just going to do the best that you can. And then the total amount of students, if we correlate this line down, is around 250, okay? So we can say that's around 250 out of 50 out of 250 students. Now, if I was to write that as a percentage, because again, they gave us that 20% statistic that we're looking for. 50 out of 250 students is roughly equal to 1 out of 5, which you can then push to 20%. Oops, that's not it. 20%. Now, obviously, this question is going to need your students to be quite confident in their, decimal, percentage, fraction conversions as well. Because, obviously in this conversion process, I have skipped a couple steps. So, already we can see this 20% stat. So we already know that Y is the answer. But I'll do another school just to show you, an example of an answer that might be wrong, right? So if I do school X, right, and then I draw that little dot down, I can see roughly that, 150 students have special education needs, right? So we can write that down. And then if we correlate this line down here, we can see roughly 550 students go to this school in total. So based on that, you might want to also simplify that and you'll get to around 3 out of 11, right? And you'll find that 3 out of 11 doesn't really correlate well to 20%, okay? And then you can go so on and so forth. So I'll move on from this question now on to question 9. Which of the schools represented in the stacked bar chart shown have been shown to have the highest proportion of students without special education needs? So they're looking for the highest proportion of students without special education needs. Now, students without special education needs are these white sections, okay? So you want to do the same thing, but instead of now focusing on the special education needs section, we're actually focusing on the other part of that chart, okay? So I think the best way to do this is first you figure out how many students go to each school in total, right? And we know that for school Y, that's about 250. For school X, that corresponds to around 550. And for school W, that'll be 350. And for school V, that would be 950, okay? Now, you want to figure out actually, because reading the white part is a little bit more difficult because you're essentially just estimating from here as opposed to estimating from 0, which is a little bit more accurate. What I'm going to do is I'm actually going to figure out which of these schools has the highest proportion of students with special education, lowest proportion of students with special education needs. And the reason why I'm doing that is because if you can figure out the schools with the lowest proportion of student education needs, right, then that school is also going to have the highest proportion of students without special education needs, right? Because this chart shows us a dichotomy, right, between those students with special education needs and those without. So if there's going to be a small proportion of students with special education needs, then those without is going to form a large proportion, okay? And if there's going to be a large proportion with special education needs, like this school, then you're going to have a smaller proportion without, right? So under that logic, right, this question is essentially just asking me for which school has the lowest proportion of those with special education needs. So similar to what we were doing before, right? You just want to figure out how much is comprised of special education needs. It's going to be 50 for the first one. This one corresponds down to 150. This one corresponds exactly to 100. And this one corresponds to 250. Okay. Now, based on these numbers, right? And this is, I think, where this question gets a little tough, right, you need to compare them, right? So there's 50 out of 250 here, which before we already figured out corresponds to 1 out of 5, which corresponds to about 20%. Okay. We have 150 over 550 here, and that will drop down to 3 over 11, right? And 3 over 11, right? We can kind of figure out that 3 over 11 is actually a little bit higher than 20%, right? So, I mean, there are a couple of ways you can try and figure this out. If you want to convert a really, awkward fraction into a percentage, you can simply just do this, right? 3 divided by 11, and you get 0 points. And then you're going to have to pull a 0 there, and you get 2. 2 times 11 is 22. Drag down the 8, 8, 0, and then you'll get 7. 7 times 11 is 77, and so forth, right? But just because we already know it's around 27%, we already know that X is not going to be the school. Okay, let's go on to the next school. We know that school W is 100 over 350, right? And that will correspond to a fraction of about 2 over 7. Now, again, 2 over 7 is a very ugly fraction, so we're going to do the same thing we just did, okay? So 20 divided by 7 goes in twice, gives us 14, pull down the 6, give another 0, and then 8 7s are 56, pull down the 4, we don't need to do any more because this is already higher than 20%. And then finally, the final fraction we got to figure out is 250 over 950, and 250 over 950 students gives us 5 over 19. And again, we just do the same thing we did before. 5 divided by 19, 0 point, just add the 0. 2 times 19 is 38. Pull down the 12 and add a 0 there. And we have, let's say 6, and that gives us 114. And we'll drag down 6, and we don't need any more because we already know that the fraction 5 over 19 corresponds to a percentage of 26%. Obviously, these numbers are all rough, but these numbers are all bigger than 20%, which already tells us that school Y is going to be the school with the smallest proportion of students with special education needs, which means it's going to have the largest proportion. Largest proportion of those without special education needs. Okay. Yeah. So obviously this question is quite heavy on the calculations, but I think this is one of the questions where I did want to do the working out for you guys, because you can do these questions by doing the eye test, or you can do these questions by doing all the calculations. And it really depends on how close the numbers look like they're going to be when you decide what you want to do. Obviously, in most thinking skills questions, if you can do the eye test, obviously, if you had infinite time, I would advise you to always, do the working out, but you don't have infinite time. 40 questions in 40 minutes is always very hard. So if you can do the eye test, I would actually suggest that. But yeah, from this, we can tell that the answer for question 9 is going to be 8. And yeah, move on from there. Question 10, the chart below shows the distribution of results this season for the Alpha Strikers soccer team. They have played 24 matches to date, and they haven't lost any matches, right? So by the distribution, right, this pie chart is showing us what proportion was home wins, what proportion was away wins, and so on and so forth. Question is, approximately how many matches did the Alpha Strikers win in this season? So, they're looking for a win. They don't care whether it's an away win, whether it's a home win, right? So that would be just the home wins and the away wins combined, right? We also have away draws and home draws, but these are essentially non-wins, right? So we can see, and this question is asking for an approximation, right? That if you look at home draws and away draws, right? These are the games that were played, which are not wins, right? These were the non-wins, right? And this roughly looks like a right angle here, right? Just this angle here, right? And it relies on you recognizing this and kind of figuring out that this is around a quarter, which means the rest of this pie chart, which is not included in home draws and away draws, which is comprised of the wins, whether they were home or away, is going to be 3/4, right? And all you need to know then is 3/4 times 24 is going to equal to 18, and your best approximation is 18, right? I mean, another thing to kind of think about as well, if you're not looking at these fractions, is the other answers are far away enough that C would be your closest approximation. 12 is half of 24, and this is obviously nowhere near half. 24 is the entire pie chart, right? But we definitely have draws in here. So 24 is going to be impossible, and 8 is even less than half. So it's going to be even less likely. So the answer there is C. We'll move on. 11, scientists recently conducted experiments with volunteers using driving simulators. These volunteers were instructed that they had to pay for time spent trying to travel from a starting location to a designated destination. As a result, these volunteers frequently broke speed limits and traffic rules to reach their destinations faster and pay less money. This experiment concluded that drivers should not be made to pay to drive on roads, as they would drive more dangerously. Which one of the following is an underlying assumption? So before the underlying assumption, just quickly summarize, what are they saying? They're saying they ran an experiment where, in driving simulators, they forced drivers to pay for the amount of time they spent on the roads, but then they found that drivers broke road rules and traffic rules in order to get to their destinations faster and pay less money, which means we shouldn't do this rule. We shouldn't put this into action. So based on this, go through the options. A, driving simulators are a reliable guide to real life driving. So this is actually a very good assumption that correlates well to what this argument is trying to make. Because if you pay attention to the question, they said that they conducted these experiments using driving simulators, right? But if you look at their conclusion, the experiment concluded that drivers should not be made to pay to drive on roads, as they would drive more dangerously. The conclusion is talking about how these people should actually drive on real roads, right? So there is an assumption because they conducted the experiment on simulators, but they're looking for the conclusion to be applied to real world driving, right? And that's an assumption that they've made. They haven't talked about this assumption, but this is an assumption that they've made. So A is the correct answer. But roughly going through the other ones, B, the experiment's results are inconclusive and may not be accurate. I mean, this could be an assumption, but it's not core to their argument, right? This is actually, rather than an assumption, it's actually going to be a flaw. So this is opposite of what we'd be looking for anyway. C, governments have recently proposed measures to charge drivers based on the amount of time spent traveling on roads. Even though it closely parallels what they're talking about, it's not an assumption. It's just an example of the information that they're giving, but it's not an assumption, right? And D, speed limits are often ineffective at limiting the speeds at which individuals drive. Again, this is fairly irrelevant, right? Option D is more looking at whether or not it's a strengthening or weakening argument, but we're just looking for assumptions, information that isn't in here, but must be here to link these arguments together to make the overall argument make sense. All right, question 12. A piece of folded paper is folded along the dotted line shown below. Then patterns are cut out from the shape as shown. So here's the paper, they've got the dotted line, right? And what they've done is they've folded this side downwards under this side, right? And then they've cut these shapes out, right? So the important thing to realize is when you cut these shapes out of a paper that's already folded, and you've got to use your visual spatial reasoning here to kind of picture it in your mind, right? These cuts are also going to come through on the other side of the page as well when it's unfolded, right? So when it's unfolded, like all these examples here, right? These cuts should be mirroring each other, right? So let's go through our options. Sorry. Okay, here we go. So if we look at option A, we can see the smile is mirrored here, and the smile is definitely in the top left corner, right? And we can see the rectangle is mirrored and the triangles are mirrored, and they're both in the right position, right? So we know A is going to be the answer. But to go through, a wrong answer, why is B wrong? Well, the shapes are all in the right spot, but when they're mirrored on the other side, we can see this smiley face. It's not mirroring correctly, right? The smiley face is upside down. So when you fold it together, these two, they're not going to, match each other perfectly, which means it's not possible that they would have been cut together, okay? And then with option C, they're clearly not corresponding at all. And option D is obviously going to be the same idea. Okay, question 13. In a survey, person A says that he's 30 years old. Person B says that she's 30 years old. Person C says that she is 25 years old. If each of them rounded their ages to the nearest 5 years, what is the maximum difference between the ages of the youngest and oldest person? Okay, so A says they're 30. B says they're 30. C says they're 25. Now, we know that they rounded their ages to the nearest 5 years. Now, thinking about rounding, right? If we look at an example, 21, 2, 23, 24, 25, right? Any age which is 22 or below will round to 20. Any age that is 23 or above will round to 25, okay? So we're looking between the youngest possible and the oldest possible age and the maximum difference between them, right? So the youngest possible age would be when we assume that person C rounded the age from below 25 upwards to 25. And we know that the youngest age possible for this to have happened would be 23, okay? And for the oldest age possible, the oldest age is going to be either one of these, right? And we're going to assume that they rounded down from an age above 30, right? And the oldest that they can do that would be around, would be exactly, 32, right? Because it was 33, it would round to 35, okay? So based on this, you know, this is our oldest possible age, this is our youngest possible age, and the difference between them, which is the maximum difference, would be 9 years, which gives us our answer C. All right, moving on to question 14. 14, the nuclear industry claims that its power stations are safe and they're no threat to people. If this is true, then why do they locate their power plants away from population centers? By doing so, they're admitting that nuclear power is dangerous to local communities. Which one of the following, if true, would most seriously weaken the above argument? Again, and I reinforce this, these questions, you always read it and re-summarize. What were they trying to tell me? What was the argument here? The argument here is nuclear industry claims that their power stations are safe, but they always move away from population centers, which seems like an admission of guilt that they're not safe, okay? So we're looking for some weakening arguments, okay? So we'll go through each option. A, reactors are located away from communities as part of an effective risk management strategy. Okay, so, you know, this is actually something that, you know, does somewhat weaken, does somewhat actually strengthen our argument, right? Because if the nuclear industry is trying to, you know, mitigate risk, right, by moving these reactors away, then it's kind of agreeing with what they're saying, which is that there is a risk that they have to mitigate, that, you know, they admit that their power stations are dangerous, right? So this is strengthening, so it's going to be wrong. We're looking for a weakening argument. B, nuclear reactors leakages can potentially cause health issues for those living in nearby communities. B is again supporting, right? We're claiming that, you know, their power stations are dangerous, even though they say they aren't. And B is supporting that, right? Because it causes health issues. So that's going to be wrong. C, nuclear power station locations are chosen based on their proximity to a natural fresh water source. Now, C is going to be the correct answer. Why? And it's not immediately clear why it's weakening. But the reason why it's a weakening argument is because C is saying that power stations their location is based on being close to freshwater source, right? And the argument that they've given us is that they're saying that they locate their power plants based on how far away they are from population centers, right? And C, so the way option C works is C is essentially giving another reason for why these power stations are located the way they are located, right? So rather than being away from population centers, they're meant to be positioned towards a fresh water source, right? So that's why C is a weakening option, because it actually, you know, argues against one of the points, the actual argument, the main argument they're trying to make. D says Australia's first nuclear power station located in Lucas Heights undergoes a regular safety inspection. This is wrong. This is going to be, you know, a real life example that's not actually relevant to the argument, okay? So option C would be the answer there. Question 15, Hussein and Jamal like to collect marbles. They decide to compare their collection as shown in the table below. So as long as you understand, these are the marble types. These are the amount owned by Hussein. These are the amount owned by Jamal. Don't bother reading all of this because there is so much information. You just need to know what their question is and then go back to the tables, okay? As long as you understand what they're trying to tell you. They would each like to sell their marbles to make some money, with the value of each marble depending on how rare they are. The values of the different types of marbles are shown in the table below. Here are the values. Whose marble collection is more valuable and by how much? So this is a question where you know what marbles each person owns and you know how much each marble is worth in terms of value. So you just need to correlate them, right? Hussein owns a marble with blue swirls. So that's going to be $2. He owns one with blue and yellow swirls, which we can see here, which is $3. And he owns one with green and yellow swirls, see here, which is $4. And he owns one which is speckled, which is $10. And that gives us a total of 4 plus 3 is 7, plus 2 is 9, a total of 19. All right. We also have the amount owned by Jamal. So the blue swirls here are $2 each. He has 2 of them, so that gives $4. The yellow swirls are going to be $2 each. The green swirls are going to be $2 each. The blue and yellow are going to be $3 each. And the green and yellow are going to be $4 each, times 2 gives us $8 in total. And he has none of the rest. So then similarly, we just add them up. 4 plus 2 is 6, plus 2 is 8, plus 3 is 11, plus 8 is $19. So we can see here that they both have a total of $19 worth of marbles, right? And so based on that, we can say that the answer is C. Both of the collections are of equal value. Okay. Let's go on to question 16. At the end of the year, some engineers at a company may be promoted to project director. If William is promoted, then Harry will resign. If Harry is promoted, then William will resign. If Megan is promoted, then Susan will resign if Harry also resigns. So this is a logic puzzle, okay? You just need to be familiar with the rules they're giving you. Megan says, if William and I are promoted, then Susan will resign. Harry says, the only way that I will resign is if Susan resigns. If the quoted statement is true, which is this one, whose reasoning above is correct? So the way you do this is go through each line and then reread the rules, see if each one makes sense. If it makes sense, then they're good. If it doesn't make sense, then you strike them off and then you go through your options, okay? So Megan says, if William and I are promoted, then Susan will resign. So if William is promoted, we already know that Harry will resign, right? If Megan is promoted, we know Susan will resign and Harry will resign, right? So we know here that what Megan is saying is definitely true, right? Like obviously William being promoted here doesn't change her logic, but just by the fact that she is promoted means that Susan will resign and Harry will also resign, okay? So if we look at Harry's logic now, the only way that I will resign is if Susan resigns. So Harry is saying if Susan will resign, Harry also resigns. But that's not true, right? What if Megan is promoted? Then Susan resigns and Harry resigns, right? So that's another case that Harry didn't consider. And also, what if William is promoted? Then Harry will resign as well, right? So his logic is wrong. So the answer is going to be A, only Megan's logic is correct. Okay. For this question, we're looking at a line graph. The line graph shows the trend in the number of households with regular use of a car from 1960 to 2000. It shows that the number of one car only households has been stable at 45% from around 1970. Okay, so from around 1970, they're saying that the proportion of one car only households has stayed around 45%. Okay. And it starts from 1960 to 2000, and this corresponds to the percentage. So question 17, during which of the following years were there a higher proportion of households with no cars versus households with one car or households with at least two cars? So that's referring to this one, 2 or more cars is the same as at least 2 cars, okay? So they're looking for one where the proportion of households with no cars is higher than both of these. Now, if you look at the lines, you know, this is the no car, the households with no cars. This is the line of those with one car, and this is the line of those with two cars. You're looking for when this line is higher than both of these lines, right? Which is going to be this period here, right? So it's going to be around this period here, right? Any year in there would fit what the question is looking for. So A, 2003 is wrong, right? That's clearly below that. B, 1997 is also going to be wrong. C, 1975 is going to be just wrong. We see that at 1975, the no car small dot line has just dipped below the one car only line. So the answer is going to be D, 1972, because here you can clearly see no cars, the proportion is higher than families with one car. And looking at question 18, if the trends continue, approximately what percentage will the number of households with no cars make up by 2010? So they're looking for an extrapolation here, right? Based on the information given, right? What proportion of households with no cars, right, will there be in 2010? So you need to just follow the trend and basically continue it, right? So a good way to go about this is to see that roughly the trend from 1970 to 2000 is kind of, a straight line, right? So what you can do about this is you can just go from, 1970 to 2000, right? And you can see that from 1970 to 2000, there has been a drop of around, I would say, and obviously you're going to have to do approximations for this. I would say it's about 20%. So it's around 20% drop in about 30 years. Now, they're looking for what's going to happen in the next 10 years, right? So in 10 years, if there was a 20% drop in 30 years, then in 10 years, it might be around, 6 or 7%, give or take, right? So 6 or 7% drop from this level, which is at the moment around, let's say, 26%, our guess is it's going to drop to about 20%. Okay. Now I'm doing the maths here, but you can actually still use the eye test, right? You can maybe just draw a line and continue to draw the line and see roughly where the line ends up. Obviously, that's not the best way, but it's something that you can try, right? But you have to keep in mind that these are going to be estimations, right? And your answers will normally accommodate for that. Your answers will normally be far enough apart where a reasonable estimation will give you a clear answer, okay? So my estimation was around 20%. And here we have the option 22%, which is going to be a lot closer than the option 16% or 36%. So the answer here is going to be C. Okay. 19. Hannah attended English class at school. The following statements were made. Again, don't read this. Go straight to the options. Which statement prove that Hannah had the attention? A, statements 1 and 2. Hannah forgot to complete her homework when it was due. 2, Mrs. Jackson told the class that misbehaving students will be spending lunchtime with her only if they had detention. So Mrs. Jackson's talking about misbehaving students spending lunch with her if they have detention, and 1 is talking about forgetting to complete her homework. These two lines of logic don't link together. They don't prove anything together, right? So A is wrong. B, statements 2 and 4. So again, 2 is just saying Mrs. Jackson is telling them if they're going to spend time with her at lunch, it's because they're having detention. And 4 is saying Hannah spent lunchtime with Mrs. Jackson. So Mrs. Jackson already said that misbehaving students spend lunchtime with her only if they have detention. And we know that Hannah spent lunchtime with her. That means the option is going to be B, okay? I won't go through the other options just because I've gone through one of these questions already. But I hope that kind of helps you out with that one. Question 20. 3 different shapes are shown below. Which of the following figures cannot be made by combining the 3 shapes? Okay, so this is another visual spatial question, right? And essentially the idea is you combine these 3 shapes in different ways to see if they can make these 4 different options, these silhouettes, okay? This can be quite hard. And my best advice for this kind of question is actually just to draw on your page, okay? So, let's look at option D. If I say, do this, I can say this corresponds to shape A here, and we'll give them letter names, so it's more clear what I'm talking about. This will correspond to shape A. And let's see. I guess we would probably, let's see, 1, 2, 3. Let's see. I think for question D, I don't see it working out. So I'm thinking actually I've allocated it wrong maybe. So something else we might want to consider is that we first put shape C in here, okay? And then based on that, we might be able to reallocate the remaining ones. So it might look something like this. So that's going to be shape B in here, and it's going to be shape A in here. So it's a bit difficult, but we can see that it does work out, right? So we'll go on to option C. Now option C is a little easier. This black silhouette here can only correspond to shape C, right? This shape here. And for the remaining part, we would do it like this, and that's shape A, and that's shape B, okay? And then for option B, I mean, what we can try and do is we'll put shape C in there first, and then we'll put shape B, and we can see shape A in here. So we already know the answer is A, based on being able to do the other 3 silhouettes, but let's see if anything works. I mean, this kind of shape here is suggesting that you put shape B in there, and at this stage, nothing else really fits that. So we can just put that in. And then, we have this little jutting out area here. So we need to address that. And there's no shape that's actually going to fit that, right? So we already know that, putting B here is wrong. And, based on this, we already concluded that, putting B in here is the only real way we're going to get a shape to fit that kind of shape, right? So we already know that from this, A is most likely going to be the answer. But my biggest takeaway from this is definitely you should be trying to draw on the page to try and piece them together. It's the easiest way of representing it. Question 21. In the 1970 Formula One World Championship, Lewitt was 1 point ahead of his rival Matt going into the final race of the season. In the race, Lewitt tried to disable Matt's car by using underhanded tactics to bump into him. This tactic was allowed, but not looked well upon. Lewitt attempted this to try to win the championship. Which of the following is the best conclusion that can be drawn from the passage above? So, A, the championship is ruthless and unforgiving. So looking for conclusions. Is this a conclusion from this passage? I don't think so. Why? Well, obviously what Lewitt tried to do to Matt by using underhanded tactics might have been, somewhat ruthless, but that's not to say the championship is ruthless, right? Because, at the end, we know that it was not looked well upon. It was not encouraged to do this, right? So we can't say that the championship is ruthless and unforgiving. B, all competitors in the championship have sacrificed a lot to get to that stage. So for this one, we actually don't know this, right? Obviously, it might be an implication or an inference you might want to draw, but it's not the best conclusion. The best conclusion is going to be something that you can immediately, get, an implication that you immediately get with making the smallest logical jump that you can make, right? Based on the information they tell you, what is the conclusion you can make, and making as little inference as necessary. So B is going to be wrong. C, some competitors in the championship are willing to do whatever it takes to win. So C is going to be the correct answer, right? Because it says some competitors, so it's not all competitors. So some, obviously people like Lewitt, are definitely willing to use underhanded tactics, are willing to do whatever it takes to win, right? And option D, another driver in the same position would have acted in the same way. We can't say this, right? Because we don't know what the other drivers are like. So C is your best answer here. 22. Andrew is practicing tennis for an upcoming tournament. The tennis court which he books requires him to pay $20 per hour on weekdays and 1.5 times that rate for weekends. So he trains for 2 hours on Monday, 2 hours on Tuesday, so on and so forth. How much does Andrew need to pay on Saturday and Sunday in total? Okay, so this question, for Saturday and Sunday in total, he did only do 5 hours on Saturday and 3 hours on Sunday. Now, you'll notice actually when I read this question, I actually skimmed past this part, right? And the reason why is because these kind of questions are, questions designed to give you a lot of information, but you students, your main goal here is to read the final question and figure out what parts of the information are actually important. What parts do you need to actually figure the question? Obviously, you need to understand what they're trying to tell you here, right? I don't want you just to skim past it and treat it like it's nothing, but you don't need to read it in a lot of detail, right? Get to the final question, realize they're only asking for Saturday and Sunday, right? He practiced 5 hours on Saturday, 3 hours on Sunday. How much did he practice on Friday? I don't care. I don't need to answer that part, okay? Now, what else is important? He pays $20 an hour on weekdays and 1.5 times that on weekends, which means he pays $30 per hour on weekends, okay? So 5 hours here is going to be 150. 3 hours here is going to be 90, and that gives us a total of 240. Answer is B. 23. Global warming has been a major issue in the past, but the effect it has on our environment today is far worse than it has ever been. Scientists have found overwhelming evidence that the Earth's atmosphere is warming as a direct result of the actions of fossil fuel industries. The carbon dioxide and methane released by these industries are the main chemicals causing this effect. To counteract global warming, we must eliminate fossil fuel industries. Okay, what are they talking about first? Because this is a long one. So before I read the question, I just want to summarize again. What this argument is saying is global warming is bad. Scientists have figured out that global warming is caused by fossil fuel industries because they release carbon dioxide and methane. So to fix this big problem, we got to eliminate these fossil fuel industries. Okay. So, which of the following, if true, would most weaken the above arguments? So, A, the greatest polluters of carbon dioxide and methane gas are farming industries. Okay, so already I think we have a very good weakening answer. Why? Well, our argument here is saying that global warming is really bad, and it's bad because of fossil fuel industries, because they release carbon dioxide and methane, right? Which is why we need to eliminate fossil fuel industries to counteract global warming. But if fossil fuels aren't even the main polluters of carbon dioxide and methane gas, right? Then that kind of invalidates our argument, because the argument might shift to we don't need to eliminate fossil fuel industries. We might need to eliminate farming industries first, right? So this is a good weakening argument. I'll go through the other options. B, human pollution has increased massively in the last few decades. Irrelevant. We're talking about the fossil fuel industry. Human pollution is too big of a scope. It includes everything, right? And that's not what we're addressing here. C, carbon dioxide levels thousands of years ago have been shown to be much lower than levels today. Well, I mean, people who are in the know, who know the science, might know this is true, but this isn't relevant to our argument, right? So this is not going to be true, not going to be correct, sorry. And D, carbon dioxide makes up around 45% of the gases. Again, it's irrelevant. It's not relevant to our argument. So A is the best answer. 24, a structure was made with some blocks and is shown below. So here's the structure. Which of the following best represents a top view? Again, visuospatial, you just need to be able to picture it from the view up here, looking down, okay? Now, we just got to look for features here, right? We can see that this square here, this block is tightly, in this corner, right? So A, B, and D could be right. C is already wrong, okay? So we'll scribble that one out. Now, if we look at this little block here, we know it's probably around the middle in terms of depth, because I can see that there's a little bit of space here, and there's a little bit of space here in front and behind of it. So we know that this block is somewhere around the middle of this block. So option B is going to be wrong here, but option A and D are still on the block. And then for this square and this cylinder, the circle and the cube, right? We can see that the cube and the circle are roughly aligned, right? They're not going to be out of line like in option D. So your best answer here is going to be A. 25. Billy the farmer owns a farm which sells the following goods. So here we are. I'm going to skim past that and go to the question. If a customer bought 1 carton of eggs and 1 jug of milk each day for an entire week, how much money would Billy earn from this one customer? So 1 carton of eggs. So 1 carton of eggs, right, which each contains a dozen eggs, costs $2 per egg. Now this wording is a bit confusing, no? But it's essentially saying a carton has 12 eggs and each egg costs $2, which means a carton is actually 12 eggs times $2 each egg, which is $24, right? And we also have a jug of milk. And a jug of milk, we know, is going to be $5 per liter for a 4-liter jug. So again, they're out to trick us. 4 liters at $5 per liter, right, gives us $20. So the idea here is that this customer pays, for some reason, very silly customer, $44 for a jug of milk and a carton of eggs each day, right? So he buys it each day for an entire week. Therefore, the total amount that he spends is 7 times 44. And we can do the working out. 4 times 7 is 28. Carry the 2. 4 times 7 is 28. Give the 2 back. And we get 308. Answer is D. This is almost like a maths question. But the idea is you just need to be able to pick out the correct information you need to use. Okay. Question 26. A folded piece of paper with a pattern cut out of it is unfolded across the dotted lines. So this is folded and then unfolded. So it was unfolded across here and then unfolded down. Which pattern best shows the appearance of the unfolded piece of paper? This is very similar to the previous question. You just need to figure out which of these has the right configuration of twos so that it will mirror across the fold. Because if you cut a shape out like this and then you unfold it there, right? The shape that was cut into this piece of paper has to be mirrored across the fold. That's kind of how it works, right? If I was to roughly draw it in, and well, this might be quite difficult, you would roughly get something like this. Right? And then once you fold that down, it has to mirror again. So you'll get something like this, and then it'll mirror. So you get something like that. Okay. So based on this, I know it's very inaccurate. You're looking for something that's kind of resembling that. And the best one is going to be option A. This is the one that best matches this kind of pattern, right? So again, drawing on the page helps, right? But ultimately, you have to be able to picture it in your mind. If you unfold that page, those shapes will have to mirror, okay? So on to question 27. There are 2 painters who must finish a paint job, one after the other. They paint at different rates. The first painter can finish the first job in 1 to 2 hours. After the first painter finishes, the second painter can finish the next paint job in 2 to 3 hours. If the 2 paint jobs must be completed by 6:30 p.m., when is the latest time the first painter should begin painting to ensure that both paint jobs are completed? Now, the important part is the first painter, 1 to 2 hours. That's how long it takes for him. And the second painter, it's going to take him 2 to 3 hours. And they paint one after the other, importantly, right? Now, they're saying, when is the latest time the first painter should start? Now, if I were to go for the latest time, right? That essentially means that you need to account for the variation because we need to ensure that both paint jobs are completed. So, if it's needs to be completed at 6:30 and he starts at 3:30, right? And even though the first guy, he might be really fast and take 1 hour, right? The second guy, ideally he might take 2 hours, but he takes 2 to 3 hours, right? So what if he took 2.5 hours, right? We cannot guarantee that they're going to finish by 6:30. So we need to be very conservative we need to give them enough time, right? So we take the maximum. We assume the first painter takes 2 hours. We assume the second painter takes 3 hours. That's how you guarantee that they're going to finish on time or at least early, okay? So based on that, we need to give them 5 hours in total. So we want them to start at 1:30. That's the only way we can guarantee that they'll finish before 6:30. Okay. Question 28. The average score achieved by the Year 4 students taking the OC exam has decreased over the past few years. The government claims the scores reflect the increased difficulty of exams, particularly in the maths section. Okay, so these questions are always written the same way. When you see like a quoted text and like 2 people's perspectives here, the question is always going to be the same. if the quoted passage is true, which the above reasons is correct, right? So you can just start going through them and seeing whether or not they're true or false. So Bella performed far below the average score in this year's OC exam. This must be due to the increased difficulty of the exams. Okay, so we know that they said the average score is low, right? Because the exams are harder, especially in maths. Bella performing below the average score, right, doesn't suggest that this is because of the increased difficulty of the exams, right? Because, Bella is an individual person, right? And if Bella performed below the average, right, that might just be because she was very poorly prepared, right? It's not necessarily completely due to the difficulty of the exams, right? Because in the STEM, they purely attribute the difficulty of the difficulty of the exams to the average score, right? But not the variations. So if I look at number 2, due to the increased difficulty of the OC exams, Lana's OC test score this year will be below last year's average score. Now, 2 is definitely wrong as well, right? So, the OC exams, they are increasing in difficulty. We don't know if they will be increased next year, right? So we don't know if Lana's OC test will be below last year's average. Also, we don't know what if Lana is really prepared. If she's really prepared, she might get full marks, even though it's a hard exam, and she could get above last year's score. So 1 and 2 are both wrong, and the answer here should be D. All right, let's go to question 29. Question 29, the prices of most products are greatly increased by the cost of advertising these goods to the public. Many people believe that the advertising does not work and does not provide any benefit to the public. Therefore, governments should ban advertising to bring down prices of products so they can become more affordable. So this is kind of complicated. So just to re-summarize, they're saying that a lot of products cost a lot because they include the cost they need to advertise them. But a lot of people think that advertising doesn't work anyways, so they should ban them. That's it. So which of the following, if true, most weakens the argument? Okay. A, studies show advertising does not affect which products customers choose to buy. So A is actually supporting the argument, right? Because the argument said people believe advertising doesn't work. And A shows advertising doesn't work, which is supporting. So that's wrong. We're looking for a weakening. B, more expensive products are often heavily advertised on TV. Again, B is just stating the facts that we already know from our STEM. Our STEM said product prices are often increased because they include the costs you need to advertise them. And B says really expensive products often are really heavily advertised. So again, it's not a weakening argument. C, advertising is thought to increase competition between companies, leading to an improvement in the quality of the products they produce. Now, C is a weakening argument, right? Because C is essentially disproving the fact that the argument says that advertising doesn't provide any benefit, because they're saying advertising increases competition, leading to improved quality, which is a benefit, okay? So C is a weakening argument. And if we look at D, advertising is currently one of the most profitable industries in Australia. D is irrelevant. We don't care about the advertising industry. We were talking about the products that they're relevant to. So the best answer is going to be C. Okay. Let's go to question 30. John needs to purchase flour to create wedding cakes for his family-owned business. Each wedding cake that John bakes uses 2 kilograms of flour. His local convenience store sells different brands of flour, and the prices and quantities are listed below. So here are the flours, the prices, and the quantity. If John needs 12 kilograms of flour to bake all of the wedding cakes, which brand of flour will cost the least amount of money for him to purchase? Okay, so key information, he needs 12 kilos of flour, and we're looking for the one that will cost him the least amount. This one just needs you to do a set of calculations, right? So here, if we use Sally's all-purpose flour, right, it's $1.80 per kilo. So we just need to times that by 12. So 1.8 times 12. So the way you do these multiplications, ignore the dot point. 2 times 8 is 16. Carry the 1, and then that's just going to be 18. And then 20.6, and then you give the dot point back, and it's going to be $21.60. Okay, And then next, if I look at sunrise flour is $3.40 for 2 kilos. So we need 6 sets of 2 kilos. So that's 6 times $3.40, right? So 4 times 6 is 24, 3 times 6 is 18, and that's going to be $20.40. So if we look at the third one, morning sunshine flour, it's 3 kilograms. So we need 4 bags of 3 kilograms to get 12 kilograms. So it's 4 times 555. So there's 2 decimal points here. So 5 times 4 is 20, give the 2. 5 times 4 is 20, give the 2 back, carry another 2. 5 times 4 is 22, and we get 22.20. And finally, we have Golden Star, which is $7.15 for a 4 kilo bag. We need 3 of those 4 kilo bags, okay? So 3 times $7.15. 5 3s are 15, 1 3 is a 3, add the 1 back, you get a 4, 7 times 3 is 21, and we get $21.45. We can see here that the cheapest price is going to be B, sunrise flour. Okay, let's go on to question 31. 31, studies suggest that the more violence and aggression that teenagers experience, the more aggressive they are likely to be to the people around them. A parent says, computer games can depict scenes of violence and aggression, and they should be banned altogether to eliminate aggression in teenagers. If the quoted statement is true, which of the following identifies a flaw in the parent's claim? So the true statement they said is violence and aggression that teenagers experience cause them to become more aggressive to the people around them. The argument that we're seeing is computer games which have violence and aggression should be banned to eliminate aggression in teenagers. So let's go through the options. A, there may be other violent and aggressive experiences which can cause teenagers to become more aggressive. Now, we're not arguing whether or not, the computer games will make them more or less aggressive. We're just arguing whether or not the computer games will make them any level of aggressive. So A is arguing that, there are other sources that will make them more aggressive, but this isn't a flaw, right? Right? It's not a flaw to suggest that, one thing causes something and something else causes that thing to become even stronger, right? That's not going to identify a flaw. B, there are no computer games which depict scenes of violence and aggression. So B is also going to be wrong. The reason why B is wrong is, and this is like a relatively common trap in questions that ask you to identify flaws. The idea of a flaw is it's meant to be a problem with your argument, right? Flaws aren't just statements that suggest that the information that was given is incorrect, right? So just because an argument says computer games depict scenes of violence, you can't say something like computer games don't depict scenes of violence. That's not a flaw. You're just presenting contrasting information. It's a weakening argument at that stage, right? You're looking for problems in the reasoning, not outside information that argues against their final point, okay? So that's why B is wrong. C, teenage violence and aggression are typically habits which are observed and learnt from their parents. Okay, so C is also going to be incorrect. The reason why is because, just because they've suggested another cause for violence and aggression doesn't mean that computer games don't cause violence and aggression, right? They're not mutually exclusive, okay? So this could still be true. This is not a flaw. And D, the depiction of violence in computer games may not have the same effect as experiencing violence and aggression. So D is the correct answer. Why? Well, D suggests that just because computer games depict these scenes of violence and aggression doesn't mean that they're equal to experiences of violence and aggression. Remember, our original information said that the studies show that if you experience more violence and aggression, you're more likely to become aggressive as a teenager. But we don't know if teenagers' experience correlates to computer games, which is why D is a good flaw in the argument. Just a heads up, guys, we are probably going to run a little over time, but I'm happy to stay on a little late to just finish up all the questions. But obviously we're not going to hold you guys. If you guys are busy, feel free to leave. There will be a recording uploaded anyway tomorrow if you do miss any portion of this. But I'll keep going. Question 32, the figure below shows the outline of a window which is intended to be composed of several panes of glass, all the same shape and size. So it's essentially saying this is the outline of a window that is made up of little pieces of glass that are all the same shape and size. Which one of the following shapes could be used to fill this window? So this kind of question is essentially asking you to figure out which of these shapes, right, can be used multiple times to make this shape, right, overall. Now, I'll tell you now that the answer is A, right? And again, this is a kind of question where you need to just use your book and just draw on it, right? If I do this, I can see that shape A fits into each of these 8 sections like this, and it's the same shape each time. So A is going to be the answer. It works, right? Can B work? Well, B won't work, right? Because if I put the triangles in like this, what's going to make this square in the middle, right? And C is not going to work, right? Because if I do C, right, they're not going to align properly. There's going to be overlapping pieces, right? And if I do D, well, D is even worse, right? D, I'm going to have one pane like this, and then the second diamond is going to go all across the other one. It's not going to work at all. So the best answer here is A. All right, question 33. Most of the deep sea has not been explored yet, meaning that there are still many species of sea creatures that humans don't know about yet. Claire, as we have not explored the deep sea yet, we have not seen any sea creatures that live down there yet. And Brenda says, as we do not know many species of sea creatures, we have never traveled to the deep sea before. So which of the following is correct reasoning? Okay, so again, if you were to summarize what they're telling you here, all right, the quoted statement is saying that because we haven't explored a lot of the deep sea, there are still a lot of sea creatures we don't know about yet, right? And Claire has said, because we haven't explored the deep sea, right, we haven't seen any sea creatures down there, right? The initial information said there are still many that we don't know about, but they're saying that we haven't seen any of them, right? Which is not true. They said there are still many, but there could still be some that we've seen already, right? That's not saying all of them we haven't seen. We're just saying many of them, right? So Claire is, the modality of her language, because she said we have not seen, is saying that we 100% have not seen anything yet. And that the modality of that is too strong. It doesn't match well with our information that we've been given. So it's wrong. Brenda says, as we do not know many species of sea creatures, we have never traveled to the deep sea before. Now, Brenda is already incorrect, right? She says, we have never traveled to the deep sea, right? But the STEM says, most of the deep sea has not been explored. So she made the same mistake that Claire did, and the answer is going to be D, right? The modality of both their languages is too strong. So it is 7:30, guys. I will keep going. And again, for those of you guys who do need to leave, because we did put 7:30 as the finish time, just check in tomorrow, and we will post the recording onto our Facebook page, onto the Facebook group. 34. The chart below shows the proportion of excess deaths in winter by age and gender in England and Wales between 07 and 08. So what is this chart? Males and females, females in black, males in white. These are age brackets. So this includes all those under 65. This includes those between 65 and 74, and so on and so forth. These are the age ranges. And the vertical axis is excess deaths in 2007 and 2008. So the question, if the under 65 age group in the chart has had their excess deaths accidentally doubled for both genders, approximately what percentage of excess deaths in females aged 65 to 74 is the excess deaths in males aged under 65? Now, this question is a little bit confusing, okay? And the reason why is because there's a lot of information to unpack. So firstly, they said the under 65 age group has had their excess deaths accidentally doubled for both genders, which means that the males should be somewhere around there and the females should be somewhere around there, okay? Now, what's the question asking? The question's asking approximately what percentage of excess deaths in females aged 65 to 74. So I'll use a different color for this. What percentage of excess deaths in females, that's this, whoops, females aged 65 to 74 is the excess deaths in males aged under 65. So males aged under 65 is going to be this one right here. And so the question is essentially asking, if you look at the excess deaths in males under 65 and compare them as a proportion to, sorry, I've mislabeled this. That should be this one. That's the male one. So if you look at males, excess deaths, if they're age under 65, compared to the females, right? You're looking for it as a proportion, right? And as a proportion, I can already see that they're actually roughly equal, right? Now, this is an approximately question, right? It's an estimation. So normally your answer will be quite clear because, you know, you're making a best guess. And my best guess here is because they're equal based on the correction they told us about, right? Then it's pretty likely that the, you know, percentage or the proportion when they're compared is going to be 100%, right? So the answer here is going to be B. It's the closest one. 125 and 75 are just too far off. Okay, question 35. 200 people were asked to name their favorite color. The results are as follows. The information was formatted into the pie chart below, but one of the colors was not recorded. Which color was not recorded in the pie chart? So this is an interesting question. Essentially, they have blue, red, green, pink, and these are the number of people who said that they were their favorite colors. And then we only graphed 3 of them. Now, a pie chart is interesting because even if you only graph 3 of them, right? Even if you only graph 3 of them, right? The total proportion of the pie chart will represent 100% for those 3, right? The remaining 4th color, right, is not going to be included at all, right? It's not part of the pie chart. So the way you want to do this is you want to roughly get an idea of these proportions and see how well they correlate to any set of 3 numbers here, right? So, you know, because this is a question where it's very hard to first principle it, or it's very hard to look at these numbers and see, maybe 95 and 32 might be correlating to 1 to 3. You might want to just start by going through the answers, right? And then taking a situation, seeing if it works, and if it doesn't work, moving on to the next one, right? So if I look at blue first, if I assume blue has not been included, then it's red, green, pink. Now, these are in proportion of largest, second largest, third largest. So what you want to do is you can just say 52, 32, 18. Does this make sense? Not really, right? Because I can kind of see that, you know, 32, this little segment here is definitely less than half of this segment here, right? But 32 is not less than half of 52. So these numbers don't work out. So I know that A is wrong. Let's try B. So let's say red is missing. Then it's the biggest one will be 95. The next one will be 32. And the next one will be 18. Do these numbers work? Well, 95 is approximately triple of 32. And I would say that at a guesstimate, this segment here is roughly a third of this segment here, right? This segment here is also going to be roughly half of this segment. So B does work out, right? And let's just try one more answer. So we have green, right? So if green was not included, then it'll be 95 here, 52 here, 18 here, right? This doesn't really work out because again, 52 is more than half of 95. Well, actually, it's just under. Oh, no, sorry. It's definitely more than half of 95, right? But this segment is nowhere near half of this segment, right? So we know that C is wrong. And if we wanted to do D as well, right? Remove the pink one, it'll be 95, 52, 32. And you'll see we have the same problem. This is nowhere near half of this, okay? So the best answer here is going to be B. All right. Question 36. People must use currency to purchase goods and services. For example, when people go shopping for groceries, they must pay money at the checkout to buy the groceries. Therefore, to be able to buy different goods and services, people must be able to obtain access to money to spend through means such as employment. So re-summarizing, what they are saying is people use currency to buy stuff, right? So therefore, to buy stuff, people need to obtain it by things such as employment, okay? So Kaya says, I observed a young teenager pay for a cheap scooter at the local outdoor entertainment store. As he is still young, he must have obtained money through his family. Which of the following represents the flaw in Kaya's statement? A, she has overlooked the difficulty in obtaining enough money to purchase the scooter. Well, that's not a flaw, right? Kaya, there's no argument to whether or not it's difficult or easy. She's saying since the teenager bought it and is young, he must have gotten that money from his family, right? Nothing to do with how easy or hard it is to get the scooter. B, people may use different currencies to pay for goods and services. This is not a flaw. It doesn't matter what currency, right? Kaya's argument isn't dependent on different currencies, right? You can still get money from your parents in yen or euros. Doesn't matter, right? C, young teenagers may still have access to employment, which would allow them to earn money. This is a flaw, right? She assumes that being a young teenager paying for a scooter means he has money, which means since he can't have employment, he must have got it from his family. But she assumed he can't have employment. Why can't he have employment, right? So that is the flaw, right? So C would be the best answer. D says she assumes that young teenagers are only able to earn very little amounts of money through employment. Well, just because they can earn very little amount of money doesn't necessarily mean they can't buy a cheap scooter. It's specified to be cheap, right? So D is also not the best answer, okay? 37, it is far better to buy a mobile phone on a fixed term contract rather than buying a pay-as-you-go package. Fixed term contracts are more reasonably priced. Therefore, everyone should choose a fixed term contract deal instead of the pay-as-you-go package when buying a mobile phone so that they save money. Again, let's re-summarize this, right? They're saying fixed term contracts are better than pay-as-you-go packages. Fixed term contracts are priced better, and therefore everyone should choose the fixed term package. So, which of the following, if true, most strengthens this? Okay. A, fixed term contracts include unlimited calls and texts for a cheaper price than the cost of paying for every minute of calls and every text as in the pay-as-you-go package. Okay, so A is a pretty good strengthening argument, right? Because they're saying it's better to buy the fixed term contract, right? And A is saying the fixed term contract comes with other benefits. You get unlimited calls and unlimited texts, right, at a cheaper price. So, I'm starting to sound like a telecom ad, but the idea here is you get more benefits and it's still cheaper. So it's strengthening the argument that fixed term contracts are better, okay? But let's go through the other ones. B, the number of people who buy pay-as-you-go packages for mobile phones is more than double the number of people who purchase a fixed term package. Just because more people buy something doesn't mean it's better. So that's not a good strengthening argument. C, the pay-as-you-go package is ideal for customers who do not call or text people often enough to make the fixed term contract worth it. So overall, C is a weakening argument, right? And so that's not what we're looking for. So that's going to be wrong. And D, both fixed term contracts and the pay-as-you-go package include enough data for most consumers. So D is it's actually a slight strengthening argument, right? But it's only very minor, right? Because it's saying that pay-as-you-go is the idea that you might not actually need that much data, right? But D is saying that even if you're on a fixed term contract, everyone gets enough data. So the cheaper one will always be better overall. But it's that's a very complicated line of logic. And overall, at the end of the day, right? It's quite weak, right? And it's not directly related to what they're trying to argue, right? So A is the best answer here. 38. On a unique die, opposing faces have dots which add to 7. There may be faces with the same number of dots. Some of the faces are shown in the net below. Okay, so when folded, what is the maximum number of dots that can be seen from one view? So this question, right, is quite hard, and it relies on a lot of tips and tricks that you might want to have, concluded. So one thing is, and this is a really good one, for dice questions, right? If they give you a dice net, an unfolded dice, it's really important to recognize that any two faces that are separated by a face in the middle, right, are going to be opposite each other, okay? So this face and this face here, they're definitely going to be opposite each other because it's separated by the square in the middle and they're in a straight line, okay? This face and this face here are also opposite each other because they have a square separating them. This face and this face are also opposite each other. Same rule. So based on that, right, the question told you that opposite faces have dots which add to 7, right? So based on that, we can already fill it in. This one will have 3 dots because its opposite face has 4 dots, right? This face here will have 4 dots because the opposite face has 3 dots. And this face here will have 6 dots because the opposite face has 1 dot. So now they're saying, when you fold them, what is the maximum number of dots that can be seen from one view? Now, you really do have to draw this one out because it's quite hard to visualize. But if you think about it from a cube, right? When you view a cube, the maximum amount of faces you'll be able to see at one time is 3 faces, okay? If I twisted this cube any way I wanted to, I would only be able to see 3 faces. And this is probably the hardest part of the question because it's not specified in the question, right? But if you draw it out, you can kind of see that, you know, there's no other way to think about this. You can only really see 3 faces at any one time, depending on how the cube is positioned, maximum, okay? So based on this, the question's asking us, right, which 3 adjacent faces will have the highest total amount of dots that we can see at one time. Why do they have to be adjacent? Well, you can only see them if they're in the same view. And if they're in the same view and you can see all 3 faces together, they have to be next to each other, right? So based on this, you need to be able to kind of fold this net in your head. And obviously this is quite a hard question, but you can see that the best answer for this is going to be 6 plus 4 plus 4, right? There are 3 faces that are going to be right next to each other. And if you add them together, you're going to get the answer 14, okay? Alrighty. Last 2 questions. 39. When a person exerts lots of energy while they're exercising, they will always feel out of breath and will sweat a lot. People who begin to feel out of breath always stop exercising and drink water. So what is the logic? They're saying that when you exercise, when you use energy while exercising, you feel out of breath and you sweat. If you feel out of breath, you'll stop exercising and drink water. Lucy says, my friend Stacy was exerting a lot of energy while she was running. Therefore, she eventually stopped running to take a break to drink water. Is this correct? Yeah, well, she says her friend Stacy used a lot of energy. So she used a lot of energy while she was running. And we already know that if you use a lot of energy, you're going to feel out of breath and you're going to sweat. And if you feel out of breath, you're always going to stop exercising and drink water. Therefore, she eventually stopped running to take a drink of water is going to be true. Okay? It follows the line of logic that we're given here. Darman then says, I watched Becca drink water because she was sweating a lot after her jog. Therefore, she must have exerted a lot of energy while jogging. So Darman is going backwards. Darman is saying he watched Becca drink a lot of water. And he knows that Becca drank a lot of water because she was sweating a lot after her jog. Therefore, she must have used a lot of energy while jogging. Is that true? Well, she could have jogged and then she might be sweating for another reason. What if she was jogging and it was just really hot? She didn't use a lot of energy, but she's still sweating. And because she's sweating, she's now drinking water, right? This isn't necessarily true. And this is a really common mistake, right? Just because a line of logic works if you go forward doesn't mean it works the same way when you go backwards, okay? So the answer is A, only Lucy's logic is correct. Question 40. Some of the greatest mammals in the world have brains many times larger than ours. It is a fact that organs do not grow or remain large unless they are used. And if they are not used, they shrink or even disappear. It must be concluded, therefore, that whales make intelligent use of the massive brains that they possess, perhaps at thought levels well beyond our understanding. Okay, what is this saying? We got to re-summarize this to ourselves. This is saying that, you know, lots of mammals have huge brains, bigger than ours, right? And we already know that, you know, an organ will only grow to a certain size if they're used. If they're not used, they'll get smaller, they'll shrink, they disappear. Therefore, whales, because whales are huge, must have massive brains. And because they have massive brains, that must mean that they use them a lot, which might mean that they think at levels well beyond our understanding. Okay. Which of the following, if true, would most weaken the argument above? A, humans believe that whales lack the ability to communicate in language. Now, this is irrelevant, right? We didn't talk about communicating in language. It's not relevant to the topic. So, B, the brains of humans have a very high density, meaning that an extremely high number of brain cells are packed into small spaces. So, B is actually a somewhat weakening argument, right? Because B is essentially arguing that just because whale brains are bigger than us, right? Human brains are really dense, even though they're not as big, which means that we can actually store a lot more cells in there, right? And we can do a lot more work because they're so dense. I know this isn't the answer because there is a better answer out there, but I am pointing out that this is indeed a weakening argument, okay? The reason why this is actually not that strong of a weakening argument is because, again, a stronger weakening argument is going to directly go against one of the lines of reasoning that you've been given, right? So this is actually not a bad line, not a bad weakening argument, right? But you can see that, it's kind of arguing against the idea that, whale brains are bigger than humans and therefore they're smarter, right? But it's arguing in a way to say that humans, that we're not dumber, we're actually also smart, right? But it doesn't necessarily suggest whether or not we're more smart or less smart. Whales might still be smarter because their brains are so big, right? They might still overall be smarter, right? So C says the large brains of whales have uses that don't involve intelligence. So C is a good weakening argument, right? Because the argument said you use an organ and it'll grow bigger, right? So they are saying that because whales have big brains, they're really smart. But what if whale brains aren't used for intelligence? What if whale brains are used for other things, right? So C would be a really good weakening argument because it directly attacks one of the lines of reasoning that you're given here. And let's look at option D. There is no connection between the size of an animal and its brain. Well, this is not a weakening argument because this is essentially just saying that one of the lines of reasoning that they get, one piece of information that they're giving is just incorrect. And that's not how weakening arguments work, right? You're attacking their argument. You're not just saying your information is wrong, okay? So the best answer here is going to be C. Okay, that was a very long session. Thank you all who have stayed as long. I'm just gonna go through some of the questions that some of you guys have thrown to me. And I'll go from the top. Okay, so someone has asked, could I repeat question 4? Okay, question 4. So question 4 here. Yeah, okay. All right, yeah. So I think the idea behind question 4, I'm not going to go through the whole question just because, we will have a recording. So you'll have an opportunity to rewatch it. But we'll just kind of repeat the overall idea of this question. And the idea is, you don't need all the information. You just need to read the question, right? And then figure out what piece of information are necessary. And the idea behind the question is you're trying to maximize the amount of prize money he could have won. Right? We already know the total amount of weight he lifted in his competitions, and you're trying to maximize the amount of prize money he won, right? Therefore, right, you need to try and make it so that over the 3 rounds, Jason lifted the lowest amount of weight possible for the maximum amount of prize money, right? And that way we're kind of creating a situation that would create the maximum amount of prize money, okay? Okay, someone's asked question 5, why can't it be D? So question 5, why can't it be D? The idea is, and obviously, for the full explanation, we can go back to the video. You can go back to the recording that will get uploaded. But the idea is option C here, right? Questions 1, 3, and 4. Statements 1, 3, and 4 directly show that Sam definitely completed the race, while statements 3, 4, and 5, right? They include a piece of information that's unnecessary, and they're also missing a piece of information that is necessary, right? Because you need to clarify that you're only offering contestants are only offered drinks once, right? Because this statement says 3 bottles of energy drink were offered to all racers who completed them, right? But what if bottles of energy drink were also given to racers in the middle of the race, right? So if someone got a free bottle of energy drink in the middle or at the end, then it doesn't necessarily mean anything if they got one, because we don't know when they got it, and it doesn't mean that they finished the race, right? So it's statements 3, 4, and 5, 1, 3, and 4 that prove it, and 3, 4, and 5 don't prove it. Okay, so let me just read through some more questions. So I'll try not to go through too many questions again, just to save on time, because I'm sure you guys would essentially be, you know, re-watching it if you would want to kind of get an idea of it again. Okay. So question 6, why can it not be C? Okay. So question 6, the reason why it can't be C for this particular question is because you know, you're introducing outside information, right? You're saying that you're arguing that, you know, so the main argument that the student proposes is that because the healthy meals cost more, people from high incomes will be healthier because they can afford it, right? But C is saying that that's not true because people from high income backgrounds can engage in other unhealthy behaviors, right? But this isn't a flaw because it's introducing outside information, right? A flaw, the idea of a flaw of an argument is not to introduce another argument that weakens your argument. The idea of a flaw is to identify a part of the argument you gave out that is wrong or that is illogical, right? C was not part of the original argument, right? C is introducing a new argument which argues against this. So C is a weakening argument, but it's not a flaw. A flaw is part of the argument that you've identified to be illogical. And that's why C is not the answer. Okay. Looking at some more questions. Okay, so someone's asking how you can use the I test for question 9. What I mean by the I test for question 9, and they're referring to this bar chart here, is essentially you're just, rather than figuring out percentages of, you know, the black bar and the white bar, right? You're just roughly guesstimating with your eyes, right? For questions that are really obvious, right? Where, you know, you can make a clear distinction. You don't need to calculate anything. You can just see, the black bar looks really small here compared to every other one. I think that's going to be the answer for the smallest one, right? But, you know, that only works for certain kinds of questions, not all types of questions, okay? And so that's why I'm saying for situations where it's a little bit closer, you're going to have to make that calculation to be sure of your answer. But in thinking skills, you do need to save time. It's a hard test and you get a lot of questions for a very little amount of time. Sometimes you can just use the I test and just get it done with, okay? Okay. I don't understand. Okay, so I mean, for question 9, I would refer you back to the explanation. But yeah, someone also did ask, am I converting to percentages? Yes. The reason why I'm converting to percentages is so that I can compare them. Okay. So what I did for question 9 was I figured out, you know, how many students there were without special education needs and how many there were in total, right? And then what I did was I did a percentage. And the reason why I did a percentage is because when you have something like 50 out of 150 and then 250 out of 950, how do you compare those numbers? It's really hard to compare fractions with different numerators and denominators, right? So when you convert them all into a percentage, it's a really easy way of comparing them because a percentage is essentially going to be always out of 100, right? You already know that 20% is smaller than 25%. But do you know if 20 out of 80 is smaller than 25 out of 90? Not really, right? It's harder. Obviously, there are tricks for that as well, but a percentage is a surefire way of doing that. Okay. Can you do 11 and 13 again? So again, I'm not going to do questions again because there is a recording, so I will refer you to that. So someone asked, okay, question 13. So someone asked for question 13, why I assumed that person B rounded down. And the idea is person A and person B are both 30 years old. And the rule is that each of them could have rounded their ages to the nearest 5 years. So in essence, it didn't matter which person I chose. Person A and person B are, in terms of the question, the same, right? It's extra information. It doesn't matter which one you use. And I assume that they rounded down from 32 years to 30 because the question was basically asking for the maximum difference between their ages, right? So if you're looking for the biggest possible difference, you're looking from the information you're given, you're looking for the oldest possible age and the youngest possible age. And the oldest possible age is going to be if someone was older than 30 years and rounded down to 30 years. That's why I assumed that the person B or person A was rounding down from 32 years, which is the maximum age. Okay. Can we do 16 again? How long should question 17 take? Okay. Question 17. This is a question where you're looking for, which year, the proportion of those without a car was higher than families with one or two or more. This kind of question should be very fast. Okay. If you understand the table, right? Once you read through this, right, you understand you're just looking for points where this line is higher than the other two lines, right? And you already have a very clear range of years for which that's true. So this kind of question should maybe take you 20 seconds, okay? The only cases where it will take you longer than 20 seconds is if you don't understand the questions, okay? At the end, question 13, I don't understand question 18. Okay, how about this? I will go through question 18 again because I think there's quite a few requests for re-explanation for that. And it doesn't seem like it's a situation of people missing it. So just to clarify for question 18, and I will refer to this line graph again. It's a line graph for families, proportion of families with no car, proportion of families with one car, and proportion of families with two or more, okay? And question 18 is saying, if the trends continue, approximately what percentage will the number of households with no cars make up by 2010? Now, this is a question which is saying, if these trends for these three lines continue, what proportion of parents will have families will have no cars by 2010? This graph doesn't go to 2010. This graph only goes to 2000, but it's essentially getting you to guesstimate by continuing the graph past where they've drawn it, right? So the best way to do this is to look at what the graph is doing. So the graph looks like it's pretty consistently going down, and to keep following that trend, essentially, right? And then that's essentially what you're doing, right? So let me kind of redraw it, and I'll move my iPad around, right? So you're essentially just following the graph down, and then you're continuing to follow it onto 2020. Now, what I did when I was doing my explanation was I did a little bit of maths. I kind of figured out how much percentage the proportion dropped by from 1917 to 2000. And then based on that percentage, if that trend continues, you can figure out the percentage it drops from 2000 to 2010. But obviously this can be a little bit complicated. What you can do is just do what I did and just draw the line out and roughly get an idea on what this is. Obviously you have to make sure that you draw the line out not too far, not too close, right? But roughly this is going to correspond to around 20%, okay? So, I mean, there is the easy way, there's a hard way. And the way I'm doing it now is the easy way, but this way can be a little bit, inaccurate if there are multiple answers that are very similar. But this is the general idea. Okay. See if there's any more questions. Oh. Question 20, question 27. Okay, someone asked for question 32, why can't it be C? Okay, question 32, why can't it be C? Okay, so I'm going to redraw this shape for you. So why can't this shape be used multiple times to make a perfect version of this shape? Okay. Now, if I zoom into this, right, you can see that if I do this shape, right, it works out for one side, but once I do it for another side, right, this corner overlaps on each other. And you can see this will happen for each of them, right? This corner overlaps and this corner overlaps. So it doesn't make sense, right? This shape doesn't work anymore, okay? All right, and that's that one. 20, 25, 27, 32. Will there be a cohort for this? I don't believe there will be a cohort set of marks for this. This was essentially just just a set of papers for you guys to try out. And obviously people haven't submitted answers for these, so we don't really have statistics for how people have done. But I mean, this was probably around standard for what you might expect from most of Alpha One's thinking skills content. Maybe a little bit harder from some of the questions that I've done today. But roughly just from last year as well, the difficulty of our questions has roughly correlated pretty well with what we've seen in the thinking skills sections as well. So, I mean, if that helps you kind of get an idea on how you've done personally, I hope that helps. But other than that, unfortunately, we aren't able to provide any cohort statistics. 17, 1, 2, 3, 4, 5, 6. Why can't question 7 be A? Is there negative marks? So no, there are no negative marks. If you get the question wrong, you'll just get 0 out of 1. You won't get -1. Doubling back, someone asked why can't question 7 be C? Okay, question 7 can't be C. The reason why is, so C says sodium fluoride has not been shown to prevent the occurrence of dental cavities in children, right? And so, you're like, the idea behind a weakening argument is it's an argument. It has to be another argument that essentially attacks one of the arguments in the stem that you've been given, right? But sodium fluoride has not been shown to prevent the occurrence of dental cavities. It's just saying that one of the pieces of information that we've used is wrong. That's not an argument. That's just like disagreeing with something that you've said, right? But it's not an argument. It's not presenting outside information that might suggest that what you're saying, the logic of what you're saying, is incorrect, right? You're not arguing the content. You're arguing another argument that will weaken your argument, right? It's not about the content being right or wrong. It's about the argument being right or wrong. That's why C is not the best answer. Okay. I can see that most of the other questions are actually just asking for repeats on questions. And I will just refer you guys to the recording. Obviously, I think the amount of people still in the call has dropped quite a lot. So for those of you guys who are still here, I will end it now.